Okay, in this video, we're going to talk about how to count atoms in chemistry. Now, just a quick review. Remember, we had discussed that elements are, one, a pure substance that cannot be broken down, and we also talked about compounds, which are two or more elements that are chemically combined. For example, sodium chloride equals salt, all right, H2O or dihydrogen monoxide equals water. But what we're going to do in this video is figure out how many atoms of each element are in those particular compounds. Now, in a compound, each element contains a certain number of atoms of each element. So what we want to try to do is identify the number of atoms of each element in that compound. Now, there are a couple of things that we need to recognize and understand first. And the first thing is called a subscript. Okay, a subscript is a number that sits below the element. So here are three examples that we'll discuss and count how many atoms are in each of these elements. So if you see a subscript next to that element, that subscript only applies to the element it follows. So here with O2, all right, that means that we have 2 oxygen atoms. Here with magnesium, we have Mg4. This 4 means that there are 4 magnesium atoms. And then here with sodium, there is no subscript. If there's no subscript present, we need to understand that there is at least 1 atom of that element. We don't need to write the subscript 1. We can just leave it without a subscript, but just understand that if there's no subscript, that means there is 1 atom of that particular element. Okay? And the subscript only applies to the element it follows. A subscript can also sit below and outside a chemical compound. Okay? Inside parentheses. Okay? For example, here in parentheses we have the compound Si2O2 with a subscript outside. Okay? Now, whenever the subscript sits outside the compound, we have to think of it as a multiplier. We are multiplying this number that sits outside by everything inside. Okay? So think of that distributive property in math class. Okay? All right. So if we have the compound of Si2O2 inside parentheses with a subscript sitting outside, we have to multiply that number by everything inside. So here, all right, we have to figure out how many atoms of silicon and how many atoms of oxygen. These are our 2 elements that we see in this compound. So here on the right, I've made my list. All right, so we have 6 times 2, all right, which gives us a total of 12 silicon. And then how many oxygen atoms do we have? We have 6 times 2, which gives us 12. So in this compound, in this whole compound, we have 12 silicon atoms and we have 12 oxygen atoms. So we have a total of 24 atoms in the compound. All right. So again, use the distributive property and multiply the 6 by everything inside, which is what we did here. In this example, we have something similar to what we just saw, where we have a compound with a subscript, but then we also have this sodium, 2 sodium atoms outside the compound, or outside the parentheses, I'm sorry. All right. Now keep in mind, the subscript in this example only applies to what's inside the parentheses. All right. Think of PEMDAS, right? Your order of operations. All right. PEMDAS, where the order of operations is P. Let's take care of the parentheses first, right? All right. So it's almost like a double step here in this example. Now, this example is probably the most complex that you're going to see. All right. But we're going to do more examples in a few minutes. right, so the first thing I want to do is eliminate the parentheses. Okay, so all right, so I'm gonna carry the two sodiums down. Then I want to distribute this 6 to everything inside the parentheses. This 6 only goes to what's inside. We do not multiply it to this. It's outside. All right, so let's look at how many silicon we have. 6 times 4, we have 24 silicon atoms. And then how many oxygen atoms do we have? We have 12. All right, so here I have a total of 2 sodium, 24 silicon, and 12 oxygen atoms. So to add these all up, all right, we have 38 total atoms. Okay. All right, so that's counting atoms using subscripts. So we're going to see subscripts inside parentheses, outside parentheses, or just attached to a element. All right. All right. The other big part to counting atoms is recognizing a coefficient. Okay. Now, a coefficient in science is a large number that is placed in front of the chemical compound. Okay, like we see here. 4 is in front of the actual compound. So we have 4 NaCl. Okay, where the subscript is just a tiny number that sits below. Well, a coefficient is a number that you're only going to see in front of the entire compound. And again, think distributive property. All right, so here this 4 is going to be distributed to everything that it follows. Okay, so here in this compound, we have 4 NaCl. So first, let's recognize the 2 elements in this compound, and then I'm going to distribute it. So I have the 4 times Na. Now, there's only 1 here, so we have a total of 4 sodium atoms. And then I got to distribute it to the chlorine. So 4 times the 1 chlorine, so 4 times 1 gives me also 4 chlorine atoms. All right, so again, I'm distributing the 4 to both elements in this compound. All right, let's do a couple other examples. All right, here in this one, we have 2 H2O2. All right, now remember the 2 is connected to the H, and this 2 subscript is connected to the O. All right, but the coefficient gets distributed to everything in the compound. So how many hydrogen atoms do we have? 2 times 2 gives us 4. And then how many oxygen atoms? Well, we already have 2, so we got to multiply it by the coefficient. So 2 times 2 is 4. Now, some years this is going to seem very easy at picking it up quick. Others, the more practice we do, the easier it'll be. But this is going to be a key part to balancing chemical equations, which is going to be the next step of this process. All right, here's another example. We have 4 PO5. P stands for phosphorus, O is oxygen. All right, so we have our 2 elements involved in the compound. We have phosphorus, which there's no subscript, so we know that this is 1 phosphorus. And the 5 tells us there are 5 oxygen atoms. But we're going to distribute this coefficient to each element in that compound. So here we have 4 times the 1p, so that gives us 4 phosphorus. And then 4 times the 5 oxygen, 4 times 5 gives us 20 atoms of oxygen. Okay, so far so good. And again, if you have to stop and pause or go back and look at these different examples, feel free. I'm just trying to give you right now 1 or 2 examples of each level of compounds that we may see. All right. And the last 2 examples are probably as complex as you're going to see in chemistry. All right. Here we have subscripts, we have parentheses, and we have a coefficient. Okay. So how do we approach this? Well, again, think of order of operations, PEMDAS, parentheses first. All right. So we have to solve for the parentheses. Okay. Now in this example, The parentheses are OH with a 2 outside. Remember I said earlier in the example, if there is a subscript outside the parentheses, it only applies to what's inside. So it's like reverse distribution. So we want to get rid of the parentheses first. Okay, so let's do that. So we have 2 times the 1 oxygen, which gives us O2, and then we have 2 times the 1 hydrogen, which gives us 2 hydrogen. All right. Now we're going to just bring everything else that's remaining. All right, so we've eliminated now the parentheses. So here is our compound. So think of it as step 2. All right. Now we have to take this coefficient and distribute it to everything inside or in the compound that's attached. So we got 2 times the Fe, 2 times the sulfur, 2 times the O2, and 2 times the hydrogen 2. So I'm going to make my list of all the elements that are in this compound. So here I have 2 times the 1 iron. So 2 times 1 gives me 2 iron atoms. 2 times the 1 sulfur. 2 times 1 gives me 2 sulfur atoms. Now over here I have 2 oxygen, but 2 times 2 gives me 4 oxygen. And then 2 times the 2 hydrogen gives me 4. So we have a total of 12 atoms in this compound. And the last example I will do in this video, all right, we have 4 Mg outside the parentheses with 3 nitrogen, 2 oxygen, 4 hydrogen in parentheses with a subscript 3. All right, so first things first, let's get rid of the parentheses, order of operations. So I'm going to distribute this 3 to everything that's inside the parentheses. This 3 does not apply to this. We'll deal with the 4Mg later. All right, so I have 3 times 3 nitrogen, which gives me 9 nitrogen. I have 2 times 3, which gives me 6 oxygen. And then 4 times 3 for the hydrogen give me 12. I've eliminated the parentheses. Now let's bring everything else that's left. All right, so now our compound is 4Mg N9O6H12. Well, remember, with the coefficient, we're going to multiply and distribute it all the way through. So let me just make my list of my elements. We have Mg, we have N, we have O, and H. So we got 4 elements in this compound. All right, so now I'm going to distribute this coefficient all the way through to get my atom count. So I have 4 times the 1 Mg gives me 4. Now I have 9 nitrogen. 4 times 9, 36. So I have 36 atoms of nitrogen. Looking at my oxygens now, I have O6, but I'm going to multiply that by the 4. I'm going to distribute it, which gives me 24 oxygen atoms. And then here I have 12 hydrogen, but multiply that by 4 gives me 48 hydrogen. And then when we add these up, it will give me the total atoms in this compound. If you have any questions, go back and rewatch the video or ask me during class.